Hello students, welcome to section 8.3 and today we'll learn how to graph an exponential function. So first thing, we'll talk about exponential growth and exponential decay. And exponential growth, the best example could be the population of the world, compound interest, okay? And the formula we'll have is basically y equals a times b to the x power, and if b is more than 1, it's called an exponential growth. And few properties: it rises from left to right, it passes through 0 comma a, which is technically a y-intercept, and something very important, x-axis will be your asymptote. And in a few minutes I will show you this using an example. So the graph of this function will look like this. Okay, if you go to your left, this graph will never touch x-axis, but it goes closer and closer. And this point is your y-intercept, which is 0 comma a, because how do you find y-intercept? You let x be 0. So same thing, it's very similar to the exponential decay function. And the best example could be if you purchase a car, the price, the value would depreciate, and also the amount of medication remaining in a person's bloodstream. So here, exponential decay, if b, which is also called constant multiplier, is between 0 and 1, falls from left to right, and it passes again through 0 comma a. And the picture will look like this. Okay? And this point is called the y-intercept or initial value, which is 0 comma a. And again, y equals abx, and the value of a is always in front of the constant multiplier. Now, we are in class. You may use a graphing calculator to graph functions or use Desmos, but our goal is to actually learn how to do this by hand. And just like we did this with other functions, we will create a table of values from -2 to 2. So make a table of values, x comma y, and pick 5 numbers. So -2, -1, 0, 1, and 2. Now, typically we start with numbers on the left side of a number line, but I'm going to start with when x is 2 because it's much easier. So how do you do f of 2? F of 2 will be 1/2 times 4 to the second. 4 to the second is 16, which is half of 16, which is 8. What's f of 1? Which will be 1/2 times 4 to the first. Any number to the first power is same number, so half of 4 is 2. F of 0, which will be 1/2 times 4 to the 0. Any number to the 0 power is 1, and half of 1 is 1/2. Just also call your initial value. That's the value of a. F of -1, which will be 1/2 times 4 to negative first. If you recall the rules of exponents, a to -n is equal to 1 over a to the n. So that will be 1/2 times 1 over 4, which is 1 over 8. And finally, f of -2 becomes 1/2 times 4 to negative second, and this will become 1/2. 4 to negative second becomes 1 over 4 square, which is 1 over 16. And when we multiply fraction, multiply numerators, multiply denominators, it should be 1 over 32. So I need to plot the 5 order pairs. Scaling is very important here. My x-axis, I need to fit numbers, values between -2 and 2. So don't go by 1, 2, 3, 4. The best way to scale this is to make this -1 and -2, to make this +1 and to make this +2. Now y values, I need to fit up to 8, and then my smallest value is 1/32, which is basically something very close to 0. So I'm just going to go by 1. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, now I'm gonna change my colors and maybe use black. Now let's plot the points. Again, I'll work backwards. 2, 8 will be this point. 1, 2 will be over here. 0, 1/2, which is my initial value or y-intercept, that will be here. -1, 1/8, it's something just above x-axis. And -2 over 1/32 is almost touching x-axis. So if you graph this, again, this may be difficult for me to do it by hand, but the graph should look like this. Now, when you go to your left, this graph will get closer and closer to x-axis, but again, it will never touch it. Just to summarize this problem, this was called an exponential growth because b was bigger than 1, and the function is increasing from left to right. So finally, I would like to present one example where we have an exponential decay. And how do I know it's decay? Because b is less than 1 but bigger than 0. Again, let's start with the table of values. So we will have -2, -1, 0, 1, and 2. And again, I'm going to work backwards. It's easier to start with positive exponents. So f of 2 should be 2 times 1/4 to the second. Okay, 1/4 to the second is 1/16, which will be 2 times 1/16, which becomes 2/16, and if you simplify, it's equal to 1/8. So 1/8. Next, f of 1, which will be 2 times 1/4 to the first. Any number to the first power is same number. So 2 times 1/4, which is 2/4, which is 1/2. F of 0. This will become 2 1/4 to the 0. Any number to 0 power is 1. 2 times 1 is 2. F of -1. 2 times 1/4 to -1st. Okay, on the side, what's 1/4 to -1st? This becomes really 1/1/4 to the first, which becomes 1/1/4. How do you divide fractions? You multiply by the reciprocal, which becomes 1 times 4, which is 4. So this becomes 4, but then you get 2 times 4, which is 8. And if you probably look at the pattern, okay, you multiply by 4, so this will be 32. But again, let's check it. (1/4 to -2) becomes 1/1/4 to the second, which becomes 1/1/16, which becomes 16, and 2 times 16 is equal to 32. Good exercise with fractions. So how do I scale this? Just like in the other example, I will go by 5 boxes will represent 1 unit, and +1 and +2. Now y-axis, I need to fit up to 32. So what's the best way to do this? I think I can go by 4, 2 boxes. 4, actually, no, that wouldn't work. 8, no, that's not gonna work. Actually, 2 boxes will be 8. So 16, 24, and then 32. Now let's plot the points. So let's use maybe red. -2, 32. So you go 2 left, 32 up. -1, 8. 0, 2. That's also called initial value, which is very close to the origin. 1, 1.5, which would be slightly above the x-axis, and 2, 1/8, which is almost touching x-axis. So if you graph this, you should get a graph that's getting closer and closer to x-axis, but will never touch it. Okay? So thank you for watching this video. And again, in this example, we were practicing all the rules, exponents. So you should take some time and make sure you understand this. Have a good day.